Good morning, everyone. Can you hear me well? Yes, great. Good morning. As I told you, can you please put your question on chat? You guys should have done the homework and tell me which questions do you have. So we can start with this. 59 from the book, okay? Any other problems? And 3E, great. All right. So it's so we start with number 59 from the book. It's 11, I guess. Yep. All right, so they want us to solve the following equation: 3 to the power 3x minus 4 equal to 15. Okay. And the whole idea is that, as we said last time, and probably as a lot of you know, that the unknown is a power. And we need a way to bring the power down. That's really the idea. And there is only one function, one thing that helps me to put the power down, which is the natural log. Because the log has the property that you take log of x to any power, you can bring the power down. And that's really the property that we will use continuously. So we say, okay, I'm going to take the natural logarithm from both sides. So the natural log of the first term is equal to the natural log of the second term. And now this is the power I'm talking about. The log can bring the power down. So this would give me that the quantity 3x minus 4, that's the power, times the natural log of 3 is the natural log of 50. And now we're back to algebra. Remember, this is a number here. This is a number here. So it's not, are not like unknown. These are numbers. We can find them. And now I need to solve for x. So I need to isolate x. So at this stage, you guys can use your basic algebra technique. Like one way, we can divide by the ln of 3 both sides. Okay, and this would help me to isolate my little x in here. And now I'm going to add a 4 to both sides. ln of 15 divided by ln of 3 plus 4. And finally, divide by 3 across. And this would be x equal ln of 15 divided by ln of 3 plus 4, the whole thing divided by 3. Questions? Okay. Is there a way we can combine those? Is there any way we can combine ln of 15 divided by ln of 3? Yes or no? Is there any way we can simplify this expression? Anybody? Make ln of 15 into ln of 5. And Nathan, you meant plus? Nathan? Yes, okay. Plus ln of 3 divided by ln of 3. Yeah, we can do that. That's correct. Can we move forward? Can we do anything beside this? What do you think? Say no or yes. I mean, don't. What do you guys think? Can we simplify this any further? Anyone? No, absolutely no. Absolutely no. There is nothing we can do about this. So ln of 15 divided by ln of 3, it has to stay ln of 15 divided by 3. The most you can do is what Nathan said. Write it like this, but you cannot go any further. Very good. Okay, now I will look at number 3E. I'll imagine this is from the worksheet.
I have a quick question.
Please go ahead.
Can't we reduce it down to ln of 3 over ln of 3 plus ln of 5 over ln of 3?
Okay, slow down, slow down. I will write whatever you tell me.
Yeah, make that ln of 5 over ln of 3 plus ln of 3 over ln of 3.
Yep, that's you can do,
Okay.
which give you 1. Yeah, absolutely correct. That's what about you can do. Yes,
And then that would be plus 5 over 3. So
exactly.
ln of 5
Exactly.
over 3
Yeah,
plus.
yeah, yeah. So you're going to end up with ln of 5 divided by ln of 3 plus 5 divided by 3. Okay, so the best you can do with that is like split it like that. ln of 5 divided by 3, ln of 3 plus 5/3. Agree? Are you with me? That's the best you can do. Yeah, all right. Okay, so now we look at number 3E. 3E. Okay. So now we're back to the homework that I assigned. So number 3E. Okay. So I'll set it up. Again, we have to solve for x. ln of x plus ln of x minus 1 equal to 1. All right, ideas, what do you want me to do in here? Anybody has any idea? The main hint is that you have to be able to find a way to isolate your ln so you can take the unknown from inside it. And I don't have that. So who have any idea what you want me to do? Exactly. So we're going to say what James said. The first step is we have to find a way to combine the ln. And the question is, can we do that? Okay, we have a sum in here. And the property of the logarithm is that if you have ln of a, now I forgot the exact letter I used last time, but doesn't matter, plus ln of another quantity, it's ln of the product. So that's how we can combine the ln. So we are going to use this exactly. So this will give me ln of. So this is a if you want, and this is the b. ln of the product is equal to 1. Now, once I have that, I need to get the ln out of the picture. I want this inside to be out. So again, now we're going to use the other property of the relationship between E and the ln. E to the ln of x is x back, and that's what we're going to use. So that's a way to get rid of the inside. So I say E to the ln of the first term equal e to the power 1. Okay, so this would give me x times the quantity, x minus 1 equal to e. So the only thing I'm doing is I'm trying to get my x outside the ln. And now I have to solve that. Okay, so this is give me x squared minus x equal to e. And how do you guys want me to solve this equation? Any ideas? Okay, this is the beginning of a quadratic equation. right? So x squared minus x equal to e. And whenever we want to solve, and that is quadratic, it means we have power 2, we have to set the right side equal to 0. So this will tell me 2x squared minus x minus e equal to 0. Now at this stage, we usually factor out. But with the e in the picture, factoring out is actually not going to be possible. So now if you have a quadratic equation that you don't know how to factor it, how do we solve the equation? Back to you guys. Quadratic equation, we cannot factor it. How do we solve it? Quadratic formula. Yes, absolutely. Quadratic formula. So the quadratic formula tells me x is minus b plus or minus the square root of b squared minus 4ac divided by 2a. Quadratic, I don't know how to solve it. Absolutely quadratic formula. So let us see the x here. And we know we have two solutions, the plus and the minus in here. So the first one will be the b is minus 1 minus b plus the square root of b squared minus minus plus 4ac divided by 2, sorry, 4e, that's one solution. And the other one is going to be 1 minus the square root of b squared minus minus plus divided by 2. So these will be the both solutions that the equation have. Are you with me how I use the quadratic? Now, in those problems, there is sometimes what we have to do is, once we have the solution, we have to ask ourselves, can we plug it in here? Now, the minute you have ln of x, it means this term has to be positive. It means if I get the solution and my solution is negative, I cannot accept it because we are working inside the ln. Also, I need the x minus 1 to be positive. So what we have to do is, in a way, estimate this value and ask ourselves, can I plug it in for the ln? Because if I have my solution is negative, we cannot accept it. So just a look at it. Let's see which one will do. This is 1 plus 4e. Now, e is like 2.7. That's going to give me 4 times 2.7. So we around 10. The square root of 11. This is definitely a negative number. So this is cannot be accepted. Because x is positive, I cannot have a negative solution because I'm starting with ln of x. This one, if we evaluate it, this is definitely going to be a positive number. 1 plus the square root, that's definitely a positive number, and this one will be accepted. So whenever we have ln, we have an issue because the input of ln has to be positive. So I am solving and I get a negative number, we have to throw it away. Cannot be accepted because ln of x defined only for x positive. Questions before we move on? So let me see how you guys handled the last problem. I mean, problem number 3, part F, and then we proceed. So we had to solve the following equation. Minus ln of x equal to 2. Again, we have to find a way to basically isolate the ln. So tell me, guys, what did you do for this problem? Idea, you didn't ask me about it. It means I'm assuming you guys did it. Anyone? Yeah, I can see Ryan wrote something. Yeah. Again, we're going to use the property of the log. ln of A minus ln of B is ln of the quantity A over B. And that's how we're going to proceed. So this would give me ln of x plus 3 divided by x equal to 2. And again, we have to do the same thing. I want to get, so I say e to the ln of this equal e squared divided by x. And now I proceed. This will tell me x plus 3 divided by x. Again, I am using e to the ln of x equal to x. This is equal to e squared. And now we solve. How do you want me to solve this equation? Quickly. Either speak or write. But let's hurry up. Multiply by 2. You meant, you didn't mean 2. What do you meant? What did you mean? Ryan, you wrote 2, but I don't think you meant 2. We're going to multiply by x, both sides, and this would give me x plus 3 equal x times e squared. And now I have to solve for x. So we have to put the x's. Remember, e squared is a number. E squared is a number, is not a variable. So to be able to solve for x, we have, and this is linear because the power 1, so we isolate the x's. Equal to minus 3. Again, I need to solve for x. I factor it out. Equal minus 3. And now I divide. Remember, e squared is a number. 1 minus e squared is a number. Those are just simple numbers. So x equal minus 3 divided by 1 minus e squared. Or 3 multiplied by negative 1 numerator denominator divided by e squared minus 1. Now, if we look at this number, we have to make sure that can I plug it for x? Well, can I plug it inside the original equation? Now, e squared, as we said in class last time, is 2.7 squared. So you're talking about it's 7 almost. 7 minus 1, that's a 6. So definitely that's a positive number. End of the problem. So this is accepted. So that's the solution. Okay. Any other question from the homework? So today we're going to finish it to finalize the log, and we're going to hopefully start the inverse function, and then we keep moving. So whenever we study a new thing, we have to know it's a graph, because the graphs are always important for us in this course and later on for you guys. So when we talked about exponential, we studied it's a graph. Now we talked about a new thing called log. We have to see how the graph looks like. So I'm going to start with the graph of the natural log. It means the log base 10, just because it is easier for us to work with. First, what's the domain? So here I'm looking at the function that you give it x. It spits out the natural log, the common log of x. It means the log base 10 of x. That's what it is. So whenever we have a function, we look at the domain. It means, can I plug in any x in here? So what's the domain of this function? Quickly. Quickly, what's the domain? Which values of x I can put inside the log? No. Remember, does the log of -1 make sense? Does log of -1. So what's the log of -1? It's the number that has the property t to the power this number is -1. Is it possible to take 10 to a power and get a negative number? Because the log is the power. Is there any power of 10 that gives you a -1? And last time we decided that's impossible because if you take 10 to a positive power, we know what it means. And if you take 10, let us say to the power -5, it's 1 over 10 to the power 5, which is positive number. So 10 to any power, 10 to any power is a positive number. Okay, so there is no way you can put anything in here which gives you, there is no power of 10 that gives you -1. It means log of -1 is not defined. So the domain is all values of x, but that x is strictly positive. Okay, very important. Okay, so let me write it on another piece of paper so I can graph. So first the domain is 0 plus infinity, only the positive values. Now the graph, how does it look like? So the only way we're going to graph this function, because I have no idea how it looks like, is by plotting point. So I'm going to plot points and then proceed. And all those values has to be positive. So I'm going to give you a bunch of values and you have to tell me what's the output. So I'm going to start with, it's positive. So I'm going to start here with 1, 10, 10 square. I'm picking very particular value. And here I'm going to take 1 over 10, 1 over 100. And you guys will have to give me answers and please give me the answers quickly. So what is ln log of 1? What's log of 1? I'm listening and reading. 0. Because 10 to the power 0 equal to 1. The log is the power. What is the log of 10? 1. Again, because 10 to the 1 equal to 10. 10 squared, quickly. Log of 10 squared, 2, for the same reason. 10 squared equal to 10 squared. Now I go back. So here I doing that, and here I'm going to sketch the graph. Okay, I'm going to put here 1. Now 10, so it's off scale. I cannot do that. 10, let us assume, pretend that 10 is here. And the output of 10 is 1. 100, I'm going to pretend it's here. That's 10 squared. And the output is 2. Now, let me go between 0 and 1 because that's the domain. I cannot take 0. I cannot take -1. What is the log of 1 over 10? Back to you guys. So 1 over 10 is right here. It's very, very, very small. We're starting with small positive number. What's the log of 1 over 10? It means which power of 10 would give me 1 over 10. Absolutely, that's -1. So log of 1 over 10 is -1 right here. What's the log of 1 over 100? What's the power of 10 that gives me 1 over 100? That's what I'm asking. It is Negative 2. We are right here. Remember, only x positive makes sense. What if I give you 1 to the power 10 to the 4? What's the output for that? I don't have room to write. So if I take 1 over 10 to the 4, the output, so log of 1 over 10 to the 4 is going to be minus 4. So 1 to the 10, 4 is very, very small. Right here, the output is going to be minus 4. So how is the graph of the log going to look like? X can never be equal to 0. The graph can never cross the y-axis. But what is the graph doing? When we're getting very close to 0, 1 over 10, 1 over 100, 1 over 10,000, the output seems to be getting more and more negative. So minus 1, minus 2, minus 4. So the graph is going to come from the bottom here, never touch the axis, and keep increasing, 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 and move very, 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 very slowly. So in word, how is the behavior of the graph of the log? First domain, x cannot be 0. Now, when the input, or when x is very close to 0, in my head now, I'm thinking 1 over 100, 1 over 1,000, 1 over 10,000. When x is very close to 0, what is the log doing? Finish my sentence. So here, 1 over 10 to the 4 minus 4. Right here, 1 over 10 squared minus 2. So what are the values of the log when x is very close to 0? Anybody can think of the answer. Okay, let me ask you this following question. Will the log ever takes the value minus 100? Is there an input? So suppose here I put minus 100, right there. Can you give me an input? Right there. So the output is minus 100. Okay, somebody tells me, yes, you're right, give it to me. Give me an input, so the output is minus 100. Anybody? Don't be afraid of small numbers. 1 over 10 to the minus 100. Very, very small number is giving me to the output of minus 100. So what am I heading to? What I'm heading to is the following. When x is very close to 0, log x takes large negative value. That's what it does. So in math, we're going to write the following. When x become close to 0, the log of x goes to minus infinity. Very important features of the log. So when x start taking very small positive, the log goes to minus infinity. Now, when x takes large positive value, when x goes to infinity, the log also goes to infinity. It means it keeps taking large positive values. So that's to sum up the graph of the log function. So the log function, you guys have it. I'll draw it one more time because as you guys know, there are basic graph we should know. So this is the graph of the log. At 1, takes the value 0. It never touched the x-axis, but it comes from minus infinity all the way up to here. And if x is 10, the graph would be takes the value 1. That's the graph of log. Now part 2 is, so that's the natural log. The graph of, so that's the common log of the natural log, y equal ln of x. Ln of x have exactly the same graph as the natural log. So the graph of ln works like this, exactly the same graph. It never, the domain is 0 plus infinity. That's the domain. And the graph is like that. This is a 1. At e, we have the value of 1. As x become close to 0, ln of x goes to minus infinity. When x becomes very large, the ln also goes to plus infinity. Important feature of the graph. So now let us practice one simple problem. Find the domain. So the question is, find the domain of the function f of x equal ln of x minus 4 and sketch. I want the domain of this function and I want the graph. So question number 1, what's the domain of this function? Okay, guys, what's the domain? X bigger than 4. Do you agree with Ryan? I need the input, this one, to be bigger than 4. So we need x minus 4 to be strictly positive. It means I need x to be strictly larger than 4. So the domain is 4 plus infinity. Now the graph. So it's ln of x minus 4. That's my function. Now if we think of shift, that's the graph of ln shifted to the right by 4 units. So how this is going to be? The graph of ln, we drew it a minute ago. Graph of ln of x minus 4. So that's the graph of ln shifted by 4 units. So this is a 4 in here. And what's going to happen is that basically it's going to look like this. And I will talk about this line that I drew a minute ago. So this is the y-axis basically in your head is going to be shifted. And the graph is going to be very close to this line, go up, and then go like this. And this would be 5. This line here, we will give it a name, and this would be called a vertical asymptote. Okay, so the line y equal to 4 will be, sorry, the line x equal to 4 will be called the vertical asymptote. The function will never touch this line, but when we are very close to 4, the function takes value closer and closer, larger and larger negative value. Okay. The last idea we're going to talk about with the log is the following, the idea of changing bases. Okay. Now, once we hit calculus, you guys will realize that the base E is actually the easiest base. So E, the base E, is the easiest base to work with. And you will see why. So a lot of time when you are working with exponential where the base is not E, we actually kind of rewrite it so the base would be E. So changing bases, first I will remind you the important fact about the log. Always e to the ln of x gives me x back. E to the ln of 2 is 2. E to the ln of 3 is 3. Another important thing we should know is ln of e to the x is x. So that's the relationship between them. And the other relationship that this one, I don't think you guys know it, is that if you have log to a base b of x, what we can show that this is the same thing as the natural log of x divided by the natural log of b. So it means that if you want to find, so log 2 of any number, what this is telling us that this is the natural log of this number divided by the natural log of 2. That's really the interpretation of this sentence. So if you want to move from a base b to the natural log, that's the formula that will help us to move. So now I'm going to write simple questions and we're going to work with them. So question number 1. Express 2 to the x as exponential with base e. Okay, so that's an exponential function with base 2. I want to rewrite it so it would be with base e. So how do we do those kind of problems? All right, we start like this. 2 to the x can be written as follows. This is my 2 here. Now, e to the ln of 2 equal to 2. So the way we can move bases is like this. Instead of 2, I substitute 2 by e to the ln of 2 because these are the same thing. And this, I raise it to the power x. So I totally substitute. So this would give me that this is equal to now the property of the exponent, an to the m, we multiply the power. And that's exactly what I'm going to do. So that's e, I multiply this by that, x ln of 2. So 2 to the x is e to the x ln of 2. So that's how we move from any exponent to an exponent with base e. So example number 2 along the same line. So now express uh, 3 to the x squared as exponential with base e. Okay. So how are we going to do that? 3 to the x squared. So let's be very careful. It's the x which is squared in this notation is equal to. Now, this is my 3. Basically, I want to rewrite it, so I bring in e to the picture. So instead of 3, I'm going to substitute this by e to the ln of 3. And this would be raised to the power x squared. And now use the property of the exponent, and we rewrite this as e to the power x squared times the ln of 3. Remember, ln of 3 is a number, you times it by that. And as I said, the reason we do this is that working with E is easy in calculus. And you will see why that's the case. Right? The last example before we change some. My question is express log base 4 of x in terms of the natural log. So this is a base. So let us remember log base 4 of x. It means you are looking for a power such that 4 to this power equal to x. That's really the log of base 4. So now I want to express log base 4 in terms of ln. And this is a formula I think you can just memorize. This tells me that log base 4 of x is basically the natural log of x divided by the natural log of 4. So that's really the conversion between bases different from E and everything that depends on E. So far we've studied several functions. So we studied the linear mx plus b that you should learn. You should know how to graph and everything, how to find. And then you guys have function that you've studied before. We have the quadratic expression, x squared, that you should know it's a graph. X cubed, that you guys should know it's a graph. The square root of x, that you should totally know the graph. The cubic root of x, that you should be totally familiar. The other function we've seen now are exponential, b to the x. Again, the graph is crucial. E to the x, that we should totally know its graph by heart. E to the minus x, which is decreasing, and the ln. So these are so far the good function that we should totally know their graph and their domain. The only one that have issue with the domain is the square root of x. X has to be positive, and the ln of x, x to be positive. All the other function, the domain is all values of x. Now we're going to move to the idea of the inverse function that, I know that a lot of you are familiar with it, but we have to review. And I'm still in section 1.3. So the inverse function. So we start the idea today. All right, so suppose I have a function f of x. Let f of x be a function. Then we are going to construct a new function called the inverse of f. And it's denoted by, that's a totally new function denoted by f inverse with a -1. Very bad notation. I will talk about bad notation tomorrow in class as follows. Okay, so we have a function. We're going to construct a new one from f called the inverse. It's denoted by f inverse as follows. So I show you how we build it in a very simple way. Suppose I have the following function f. So this is my function f. Okay, and this function takes, let us say, very simple scenario: 1, 2, 3, and let me see, 4, 6, and 10. And this function does the following. It takes 1 to 4, it takes 2 to 10, and it takes 3 to 6. That's my function f. So f of 1 is 4, and so on and so forth. Now, what is f inverse? F inverse is the following function. I'm going to draw exactly the same thing right here. And I'm going to put 4, 6, 10, and 1, 2, 3. So f inverse is going to do the opposite. It basically is going to undo what f does. So it's going to take for input the output of f. So this is my f inverse. So it's going to take for input. So the input of f inverse are the output of f. So it's going to do the following. If f takes 1 to 4, f inverse is going to take 4 back to 1. F takes 2 to 10. F inverse is a new function. It's going to take 10 back to 2. F takes 3 to 6. F inverse is going to take 6 back to 3. So whatever f does to a function, to an input, f inverse will undo it. So in this scenario, f inverse of 4 is going to be equal to 1. F inverse of 6 is 3. And F inverse of 10, F inverse of 10 is going to be equal to 2. So that's really the idea of F inverse. So mathematically, let us define F inverse. So what is F inverse? Okay. So the idea of F inverse is the following. That's the basic idea. If a function f takes a to b, F inverse is going to reverse it. It's going to take b to a. So what is F inverse of b? That FBF1, what's F inverse of b? F inverse of b is the number x. Is the number x such that f of x equal to b. Or if you want, it's the number a such that f of a equal to b. So f inverse of b is the number a such that f of a equal to b. So f inverse of b equal a means that f has takes a to b. Now, the domain of f inverse. The domain of f inverse is the range of f. Because f inverse takes for input the output of f. And the range of f inverse is the domain of f. The output of f inverse are the input of f. So let us take a graphical example to work with the f inverse. So I'm going to sketch a graph best possible way. So example number 1. Okay. Let me take the following graph. I will graph it very, very slowly. Here. So this is a 2 right here. Suppose my function is a line like that. This point here is 1, 3. And this point here is 2, 4. And then my function kind of change a little bit like that. This is point -1. And this is a point, let us say, I give it -2, -2. Right? Now I'm going to ask you several questions. And this is the graph of a function f. I'm going to ask you several questions and hopefully you guys give me a quick answer. So question number 1 is very straightforward question. What is f of 1? Quickly. I want very quick answers because it's simple. F of 1 is equal to 3. Now, question number 2 is, what is f inverse of 1? What is f inverse of 1? So it means here, I need to find the x. That's what f inverse of 1 means. I need to find the input of x. That's that f takes to 1. That's what's f inverse of 1. It means, okay, what x? F takes to 1. So I'm seeing 2. The output is 1. That's the output. Is 1. Why you minus James giving me minus a half? Exactly. That's the output is 1. I am after that value here. This is f inverse of 1. That's f inverse of 1. Okay, so that's an output value. I'm asking myself which input gives me an output of 1. So this is the one. So f inverse of 1 is minus a half. That's what f inverse is. So the input of f inverse is basically the output values of f. All right, two more questions before we finalize. What is f of 0? Of course, the first one is simple. What is f of 0? F of 0 quickly, 2. Everybody tells me 2. Very good. Now, what is f inverse of 0? Now I have totally different change. The 0 here, that's an output of f. So the question is, I want you to find x such that f of x equal to 0. So it's minus 1. This here, this is f inverse of 0. My last question, what's the domain of f inverse? Domain of f inverse. I put the picture here. What's the domain of f inverse? It means the input value. What input does f inverse take? All real number. Okay, James, if I ask you what is f inverse, let me ask you the following question. Find the f inverse of 5. What would be your answer? F inverse of 5 means 5 is an output value. So I'm asking you for the input that gives me an output. And there is no input that gives me an output of 5. So what's going to be the domain of f inverse is basically the range of f from here to here, as Vivian said. So this is minus 2 and this is 4. This piece here, right there, that's the range of f, which means that's the domain of f inverse. That's the domain of f inverse because f inverse takes for input the output of f. Ratio, yeah, absolutely correct. So the domain is going to be, now according to my picture, minus 2 and 4 are included. So the domain is going to be closed, minus 2 and closed at 4. Because minus 2 and 4, according to the picture I gave you, seems to be included in the range. Okay. All right, that's it for today. I hope tomorrow I'll see you in class and we can discuss the quiz. So please do your homework and we will discuss it tomorrow. All right, we will discuss it tomorrow. Are you with me? Tomorrow I will discuss that. All right, there is no quiz tomorrow. There is no quiz tomorrow. We will discuss the quiz on Friday tomorrow in class. Any other questions? All right, so please do your homework for tomorrow, and I hope I'll see you in class. Bye bye, guys.